Hello everyone, welcome to Unit 3, Lesson 2. Today we're going to be learning about the difference between recursive and explicit equations. Alright, so objectives and goals. We want to identify the differences in explicit and recursive equations for sequences. We want to be able to build recursive equations for sequences and use recursive and explicit equations to predict future terms in a sequence. Alright, so recall in the last lesson we worked on creating multiple representations of sequences. We did the table, the graph, and the equation, and we did this for sequences that were generated by multiplication or addition type patterns. One of the representations we learned about was the equation, right? And this was probably the most difficult for most students that work through the lesson. Building the equation can be a little bit confusing because the format changes depending on the type of pattern that we're dealing with. All right, so when we built those equations in the last lesson, we were actually building explicit equations. Okay, so what is an explicit equation? Well, these types of equations relate each term in the sequence directly to its placement in the sequence, right? So in simpler terms, it relates location and the term value. So if you tell me where you're at in the sequence, I can tell you what number it is, okay? That's what an explicit equation does for us. So just a little bit of a summary from the last lesson, right? When we had sequences that add, this was the format that we used to build our explicit equation. So if you recall f of 1, so this piece right here was a fancy way of saying the first term, right? So we would put the first term right here. This number d, right, is what we were adding by, right? We called it a common difference. So once we identified the pattern, if we were adding by 3 or 4 or whatever it was, that number that we're adding by would go in front of the parentheses, okay? When we had sequences that multiply, right, so the numbers were growing because of multiplication, we used this format for our explicit equation. So again, that f of 1 term, we see that again, it's just a fancy way of saying the first term. So we had the first term times this b value, and the b value is what we are multiplying by, and we called it a common ratio. Okay, so again, just a recap of how we built the explicit equations. We are going to be doing some of those again today, so we want to make sure that we have these down. All right. But we're also going to be learning about how to write something called a recursive equation. All right, so what is a recursive equation? Well, recursive equations relate the terms of a sequence to the preceding terms of the sequence. Okay, so in simpler terms, the equation tells us what to do to the prior term to get the next term. Okay, or it could tell us what to do to what we call the current term to get to the next term. So recursive equations, kind of like an instruction manual on how to get from one term to the next. Easy way to put it, okay? We typically write recursive equations with sequence notation, so we'll see the a sub n stuff quite a bit when we talk about recursive equations. It's probably the easiest way to write a recursive equation. So we're going to study the table below. We're going to take a look at this table and just kind of talk about the different notation that helps us keep track of the different terms as we write these equations, okay? So a sub n should look familiar. We've seen it before. And what I want you to think of this as, I want you to think of it as the current term. This is the term that we're focusing in on, the one that we're looking at. Then we could say that a sub n plus 1 would be the next term, right? So if I'm looking at term 4, then the next term would be whatever term 5 is, right? So when we say a sub n plus 1, this is a fancy way of saying the next term. Okay, so likewise, if a sub n is the current term that I'm looking at, then a sub n minus 1 is a fancy way of saying the previous term. Okay, so the term that comes before this one. All right, so let me show you what I mean here, and this is actually not that difficult. So it says I have a sequence here, 3, 6, 9, 12. So pretty typical sequence here. Looks like we're adding by 3. So it says if I set n equals 3, right, then that would be the third term. We know that we would be here at 9. Okay, so this is what I'm going to call the current term. This is the term that I'm focusing on, the one that I'm currently at. So we're going to say a sub n equals 9. So then a sub n plus 1, again, a fancy way of saying the next term. What comes after 9? Well, in this sequence, 12 comes after 9. Okay, so this would be the next term. This, a sub n minus 1, we said was a fancy way of saying the previous term. So if I'm currently on 9, then the term that comes before it, or the previous term, is 6. Okay? So again, this is just to get familiar with this notation, the sequence notation, where we see the a sub n plus 1 and the a sub n minus 1. All right, let's do it one more time, and then we'll actually get to writing an equation here. So again, I have a sequence, 3, 6, 12. This is term 1, term 2, term 3. Looks like we are multiplying by 2, because 3 times 2 is 6, 6 times 2 is 12. So I think I am pretty familiar with this sequence now. And it says if n equals 3. Okay, so if n equals 3, then we are here 1, 2, 3, we are at 12. Okay, so 12 is my current term, right? So remember, a sub n is the current term. All right, and remember, a sub n plus 1 is the next term, right? The term that comes after the 12. Well, there's nothing there but the dot, dot, dot. And all the dot, dot, dot tells me is that the sequence continues, so I need to continue the sequence to figure out what the next term is. Since we are multiplying by 2, I would do 12 times 2, and we would figure out that the next term is 24. Okay, a sub n minus 1, we've said before, that is the previous term. Right, so if I'm at 12, the term previous to 12 would be 6. Okay, so there we go. All right, so hopefully that helps out with the notation. Let's actually write an equation now. So we're going to go to the next page. I have a sequence here, so we're gonna start working on the equation for this in a recursive format. So we've got 3, 6, 9, 12. What is the pattern, right? It's always the first thing we should look for is the pattern. This is adding 3. Okay, so we've got a pattern of adding 3, no problem. Now the way to remember how to write these is to think, what do I need to do to the previous term to get the current term? All right, so in words, I need to take the previous term, right? So if I'm at 9, then the previous term would be 6. To go from 6 to 9, I have to add 3 to the previous term. All right, so we would say the current term is equal to the previous term plus 3. And then the other thing that we have to do is we have to define where the sequence starts. Right, so if I'm looking at my sequence, it starts at 3, so I just say the sequence starts with 3. So now I'm going to say this with math, right? The current term, we know that is a sub n, equals, right? So we see equals to the previous term. Okay, previous term we said was a sub n minus 1. Okay, so we've now got the previous term in there, and then we say plus 3. So plus 3. There it is. That is a recursive equation. The only thing I have to add to it is the starting point, so I have to define the first term. So I'm going to say a sub 1 equals 3. Now it is complete. This is a complete recursive equation for a sequence that adds 3 each time and starts at 3. Okay. Another way that we could write this same sequence with a different recursive definition, all right, is to define it based on the next term, right? So notice this one says the next term, which we know can be written as a sub n plus 1, right? This is how we represent the next term. This is going to be equal to the current term, right? And we know the current term can be denoted by a sub n, and then we have plus 3. Okay, and then again we just have to define a starting point. So again, it's going to start at 3, and there we go. So this is another way to describe this sequence with a recursive equation. So rather than starting the equation off with a sub n, we just started it off with a sub n plus 1, right? So both of these represent the same sequence. Okay, so that's it. Nothing to it, not too difficult at all. Let's try one more together, and then I'll let you guys pause the video and do one on your own. Okay. Okay, so here's a sequence 3, 6, 12, 18. Well, let's see what's going on here. 3, 6, 12. Ooh, I think I made a typo here. I meant for this to be a multiply by 2, which means this should be a 24. Typo alert. That should be a 24. Okay, so the pattern here is multiplying by 2. Now the nice thing about the recursive equations is that it doesn't matter if it's adding or multiplying, we're essentially going to do the same thing to write our recursive equation. We don't have to worry about different formats. All right, so again, the way to remember these is to think, what do I need to do to the previous term to get the current term, right? So in words, the current term, okay, is equal to the previous term times 2. Okay, so whatever the term was before it, I multiply it by 2 to get to the current term. So I'm going to say, and I should say the current term, right? So the current term, which is a sub n, is equal to the previous term, which is a sub n minus 1 times 2. So there we go. And then just define a starting point. You always have to get that starting point. You have to tell me what a sub 1 is going to be. So I just go to my sequence and I see it starts at 3, so we'll say a sub 1 must equal 3. All right. So let's do it one more time. This time we're going to do it with an a sub n plus 1. So we're going to say the next term, right? Rather than the current term, we're going to start off with the next term is equal to the current term times 2. There we go. So that's what it would say in English. So we're going to say the next term, which we know is a sub n plus 1, is equal to the current term, which is a sub n, times 2, where the sequence starts at 3. Okay, so there we go. These are recursive equations. All right, now what I want you to do, I want you to try a few on your own, see if you can get these 3 here. And then what I'll do here is I will just put the answers underneath so you can kind of check yourself and see how you're doing. All right, so go ahead and pause the video, take a few minutes, give these a try, then play it again. All right, welcome back. Here are the answers to the 3 problems that I wanted you to try on your own. So notice that the instructions did say to write 2 recursive equations for each. So you should have written the a sub n and the a sub n plus 1 version. You can see either of these on the test, so that's why I'm trying to prepare you for both. But again, if you recognize the pattern here, you can see that we are subtracting 8 each time. So you can see that subtraction of 8 in each of the recursive definitions. You also see that the sequence is starting with 9, so we have defined our first term. All right, looking at B, this is a sequence that is adding 2 each time, so you see your plus 2 in each of the definitions that we wrote there, with the starting term or the first term being 12. All right. Now this one was a challenge. This was the Fibonacci sequence. We saw this in yesterday's lesson. This is a very special sequence. And if you were able to successfully write the recursive equation for this one, good for you. So the way that we write this one, we say current term, right? So if I'm on term 3, then the way that we get that 3 is by taking the 1 and the 2 and adding them together. So the previous term and the previous term, right? We have to add those together. So here's the current term, here's the previous term, right? And then here's the previous term, right? So if n minus 1 takes us 1 step back, then n minus 2 would take us 2 steps back. So this would be previous term, then the one before the previous term, and we want to add those to get our current term, all right? The other thing that's special about the Fibonacci sequence is the way that it starts. It starts off with the same number twice, 1 and 1. So we have to define not only a sub 1, but a sub 2, the first and the second term for the Fibonacci sequence, because it needs 2 numbers to get started, okay? The alternative way of writing it is saying a sub n plus 1, right? So if this is our current term, then the next term is 5, okay? And the way that we get 5 is by adding the current term and the term before it. So we need the 3 and the 2. So that would be a sub n and a sub n minus 1. And we would have to add those together. Again, we have to define the first two starting numbers because of the nature of the Fibonacci sequence. Okay, so let's go ahead and move on. This next page has a little bit more practice for you to try. So go ahead and attempt the problems on this page, right? So you got some identification of things that are recursive or explicit. So think about what the difference is between those two things, recursive and explicit, what they look like, what you tend to see in the equations. That'll help you decide which ones are which. And then you're gonna work on these ones down here. So I'm gonna do the same thing. I'm gonna ask you to pause the video, try to work through these problems on your own. Then when you resume the video, I'll have the answers on here for you so you can check yourself, and I'll quickly go through them and give you some pointers. Okay? All right, go ahead and pause the video. All right, welcome back. So here are the answers. So as I scroll through this, make sure you're checking yourself, see where you have made mistakes. So we went explicit, recursive, recursive, explicit, recursive, explicit. The trick to these problems is to look for the different formats that we have used, okay? So you should recognize this one as the explicit format for an adding sequence. And you should recognize when we're using things like next term, previous term, current term, right? So with this one, I see a next term and a current term type setup, which tells me that it's recursive because I'm defining the next term based on the current term, right? Similarly, over here, the current term is being based on a previous term, so that is what a recursive equation does. So this one's explicit. This one is explicit. This is the format for a multiplying sequence for an explicit equation for that one. Okay, so you've seen enough of them to look for the clues, and you should be able to just look at one of these equations and tell this is explicit, this is recursive. Okay, so what we're going to do in these next problems, we're going to write all the equations for a sequence so we can compare them side by side. So let's take a look at these ones, if it'll let me scroll here. There we go. There we go. So we have a sequence, and it is -4, -1, 2, 5. So the first thing we want to do is identify the pattern. Hopefully you identified it as a pattern where we're adding 3 each time. Then it says, what is the common difference? Obviously, that's whatever we're adding by. So when you identify the pattern, you actually found the answer to this question. The common difference is 3. All right. The first term, really easy. Just look at whatever the first number is in the list. So that in that case, it is -4. All right. And then we have all the information we need to build the recursive equations and the explicit equation. Okay. So you can see those set up here. And make sure, again, just seeing these side by side, pay attention to the differences between them, right? Because I'm going to ask questions about those on the test and the quiz, like the differences between recursive and explicit, okay? This one, right, find the 30th term of the sequence. The easiest way to do that is to use the explicit equation. This is the best one for predicting future terms, because all I have to do is change the input to whatever term number they're interested in. So if they're interested in the 30th term, I go to the input, I change it to 30, and I then go into the equation itself and replace n with 30, right? And then just use order of operations to evaluate. So what this is telling me is that I put a 30 in, I got an 83 out, and that means the 30th term is 83. Okay, so if I were to extend this sequence all the way to the 30th term, this is the number that I would see there. Okay, one more time here, we've got another sequence, 5, 15, 45. The pattern here, we're multiplying by 3, 5 times 3 is 15, 15 times 3, 45, so forth and so on. What is the common difference or ratio? Well, it's whatever we're multiplying by, right? So we are multiplying by 3, that is our common ratio. All right, what is the first term? Well, it's right here. So we've got all of the key information that we need. So again, you see the setup for the equations. I went over these in previous problems, how to do that, so I'm not going to do it again. But again, make sure you're paying attention to the differences. Remember, the explicit equation for a multiplying pattern is different than an adding pattern. All right, but the setup is the same when I go to ask you to predict a future term, right? So if I tell you the 10th term, use that explicit equation, replace the input with 10, and then calculate and tell me what the 10th term is. Okay. All right, so let's go to the next page here. All right, so these ones, again, I want you to try these on your own. So you'll pause the video and then come back and check your answers, make sure you're doing these right. But this is another multiple representation, so you want to get the table, graph. This time we have explicit and recursive equations that we want to find, and then a prediction for a future term. All right, so when you do the recursive equation, I only need one of them this time. You pick. You can do the a sub n or the a sub n plus 1 format. I really don't care. All right, but pick one, make sure you know how to write it. So go ahead and pause the video, give this one a try and the next one, and then resume the video and let's see how you did. All right, welcome back. Hopefully you made it through the problems and found all the representations and the equations. So go ahead and take a look at mine here. So we've got -8, 4, 0 just running across the table here. The equation, remember, we treat these as ordered pairs. So this is like x and y. So one of our ordered pairs would be 1, -8. And we can take that down here and plot that point. And we would just repeat it for every pair of numbers that we have in our table. Okay. Remember, sequences that add, like this one does, like this one adds 4 each time, it's going to create a line. All right. And the other big thing to remember with the graph is don't connect the dots. Right. Sequences are not continuous. There's nothing in between these points. That's why we don't connect them. All right. Equations. Right. So we got the table, we got the graph. The equation here is our explicit equation. Here's our recursive. I went with the a sub n approach and defined it based on a sub n minus 1. So remember I said we were adding 4 each time, so we can see that plus 4 here. And then don't forget to define your starting point, right? So you have to tell me what the first term is so I know where to start this recursive equation, okay? Predicting, right? So it tells us to predict what the 50th term is going to be. So I'm going to go to my function. I'm going to replace the input with 50, which means I'm going to replace the n with 50, calculate. You should get 188, right? So if I were to continue this table all the way to n equals 50, I would see a 188 in the f of n slot, okay? So let's go to the next one here. So this is 10, 20, 40. So hopefully you identify the pattern right away. This is a multiplying by 2 type pattern. So table, right? And then our equation. Remember, the format for a multiplying equation is different than an adding equation. That's why this looks slightly different than the explicit equation that we wrote up above. All right. Again, for this one, recursive, I went with the a sub n approach. You can see the times 2, that's our pattern that we see in the numbers there with a defined starting point. Okay. And again, to make a prediction, I would use the explicit equation and replace the input with 14. All right. On the graph, we notice this is not making a line, but this seems to be making a subtle curve right now. We call this an exponential curve. Again, don't connect the points. There's nothing in between these points. All right. So that is it for that page. We're going to move on to the next page here. And again, I want you to try these ones on your own. When you are done, you've done everything you can do, go ahead and resume the video, and we'll come back together and look at the results of these problems. All right, so go ahead and pause the video one more time. All right, welcome back. So here we go. Let's look at part A. It says list the first 5 terms. All we have is the recursive equation to go on, right? So they always give us that key piece of information. The first term is 12, so I start by listing that, and then it tells me what to do from there, right? So if I want to find the current term, let's say the current term is the second one, then I got to take that previous term and subtract 5. So I'm going to do 12 minus 5 to get 7. And then I'm going to repeat that again, right? So I'm going to do 7 minus 5 to get 2, then 2 minus 5 to get negative 3 minus 5 to get the negative 8. So you can see the pattern right here, and you can see the starting point right here. So we start with 12, and then we just subtract 5 over and over and over again until we have our 5 terms. All right, explicit formula. All right, so the explicit formula, we need two key pieces of information here. We need the common difference, and we need the first term. All right, so common difference and first term get plugged in here and here to the format that I've shown you before, and that builds our explicit formula, or the explicit equation. Okay, the explicit equation is great for doing stuff like this. So they want us to find term 6, right? So find the value of term 6, a sub 6, and the value of term 100, which is a sub 100. So I'm going to go to my explicit formula. I'm going to change the input to 6, which means I change the n to 6, and then I calculate. We get negative 13. So I can tell you the sixth term is negative 13. I can repeat that process, this time with a 100. Right, so we see where we plugged in for n, and then calculated, and we find that the 100th term will be negative 483. Okay. All right, so next sequence, again, this one is saying that the next term is equal to the current term plus 3, and we're starting this pattern at 5. Right, so here's my 5. I'm going to take the current term, I'm going to add 3, so 5 plus 3 is 8. Then I repeat the process, I add 3 again and again and again, and that generates my sequence. Okay, so there's the first 5 terms. Now to write the explicit sequence, same process as we did in the last problem. Make sure you know your common difference, make sure you know your first term, plug them in, right? That's all there is to writing the equation. Then we want to make predictions about future terms, so this is telling us to find the value of term 8, so I plug in an 8 for n, and calculate. We find that 8th term will be 26. Same exact process, except this time with an 87. Okay, then you calculate and you find that 263. Alright guys, that is it for lesson 2. You should be more than well prepared to do the homework problems in MyOpenMath, so make sure maybe take a break or something, come back a little bit later and do your homework. Make sure that you don't get too far behind because of this quarantine thing. Alright, if you have questions, email them to me. I'll do my best to try and answer through email. Otherwise, make sure you jot down important questions on your notes so that you can ask them when you return to class. All right, guys, have a great day.